Hello, everybody. Thank you for joining us as we do this Ask Me Anything with a very kind of cool hackathon that we have going on this week. So this will be our Qualcomm by Google LiteRT hackathon, and this is you can kind of think of this as the pre-kickoff, the pre-game before the hackathon actually starts on Thursday. Just a high-level overview. We'll be going through why LiteRT, the benefits of LiteRT. Then we'll take you through a journey, a developer workflow of how to use LiteRT to get models delegated to Hexagon, which is Qualcomm's NPU, to make models go bird, super fast. So we're also joined. I mean, you've seen me before. Kartiki. We have Aishika. This is her first one, so everybody say hello. But we're also joined by our guests from Google, who are part of the LiteRT team over on that side. So being that they're our guests, we'll go ahead and do introductions, starting with them, and then Kartiki, and then we'll go ahead and get right into it.
Hi, good morning, good afternoon, good evening. My name is Chintan Parikh. I'm a product manager on LiteRT. Excited to be here and looking forward to the hackathon.
Hi, my name is Erin Walsh. I'm a developer relations engineer for LiteRT and Google AI Edge, and also really excited to be here. Can't wait to see what you all build.
Cool. Hey folks, I know some of you know me because we did a lot of streams with Eric in this way. But yeah, again, introducing myself, my name is Karthike. I'm a senior developer at Qualcomm, and majorly I work with on-device. And yeah, I'm so excited to basically here to share you how going through all the developer workflow that we built for. But next to Ashika, I guess. Yeah.
Hello, everyone. I'm new here. I'm Aishika, and I'm joining the developer relations team as a product manager. Super excited to be here and walk you folks through all the cool stuff that we have planned with LiteRT and Qualcomm this weekend.
Awesome. So let's go ahead and just get right into it. We'll start off with Chintan, who will talk about why LiteRT, the importance of LiteRT, and why you should be using this for your edge deployment. Go ahead, kick it off.
All right, give me a second. I'll just share screen. All right, I am sharing. Hopefully, folks can see my screen. So, all right, cool. Can you guys see it? Yes?
Yes.
All right, perfect. Okay, so yeah, my name is Chintan Parikh. As I said before, I'm a product manager on the Google AI Edge team responsible for LiteRT. I just want to kick it off with a little bit of a background. So like now that most of you are here listening to this topic, I'm pretty convinced that you're interested about the benefits and the prospects of running AI on device, right? So I just want to level set on this call and give you some background on what AI Edge is, what is LiteRT, what is LiteRT LM, and we will also give you some guidance on some exercise or pre-work activities that you can do. So essentially, we want to explain that customers often need apps where low latency is critical. For example, with every frame of video stream needs to be processed when you're offline. Especially it's critical to be able to have those user experiences be rich, especially real-time user experiences. Privacy is another major benefit if you have details that you are looking to keep on device. Other benefits are going to be offline use in different scenarios, and we are going to go over some of them. And finally, savings is definitely a benefit. With the cost there is also benefit of running some of these inferences locally that can help you be more economic with some of your applications. So with that, let's dive into the Google AI Edge stack. So when you need to run AI on the edge, AI Edge has all the tools you will need. This includes optimized runtimes, tool suites, training examples, support, and documentation. Right. So the way it starts is you have your app. We have a couple of options here. So this hackathon is not going to cover over media pipe, but that's essentially a pipeline or essentially a framework that runs on top of LiteRT, LiteRT LM. We have LiteRT LM essentially is our framework for running AI or LLM on device. And this is powered by LiteRT, which is our foundational runtime for running AI on edge devices. So LiteRT is going to be specifically useful for folks in the hackathon running any classical models, and LiteRT LM for anyone running LLM or generative models. What I also want to establish is that LiteRT supports CPU, GPU, and NPU acceleration. So we will be sharing details on how to run inference on all three accelerators on mobile devices in this hackathon. I also want to stress that LiteRT, for those who are not familiar, is basically the same as TensorFlow Lite. And this essentially is built on TensorFlow Lite that is extremely established. Developers have been using this for some time now. Here's some stats, right? We have hundreds and thousands of apps that already run on TensorFlow Lite. We have billions of users that use TensorFlow Lite. And we have a lot of instances already that are doing inferences daily with TensorFlow Lite. And all of this is basically followed up with LiteRT, which is essentially improvements over the TensorFlow Lite that you already know. LiteRT essentially expands its role in many significant ways. It's the same TF-Lite model that you had used on your existing apps that is also usable or operational on LiteRT as well. So LiteRT is a cross-platform runtime framework that is supportive of these CPU, GPU, NPU accelerators and runs on Android, iOS, macOS, Linux, Windows, IoT, and also web. In this hackathon, we are going to specifically focus on LiteRT LM and LiteRT, and Karthikeya, Erin, and Aishika will go over the tracks, but this is going to be the major focus of this hackathon. So a lot of the content is going to be focusing around bringing your own model type of use cases versus using some turnkey solutions like that are often provided by, say, MediaPipe tasks. So this is a big focus for those who are looking to bring their own models and build their own applications. So just to recap, LiteRT is Google's on-device framework. It's fundamentally built on trusted foundation of TensorFlow Lite, as I mentioned. So there's a lot of apps out there. It's using the same TensorFlow Lite model and maintains the proven stability of TensorFlow Lite. So you're going to basically be able to run your own devices. Tensor in, tensor out is where you would use LiteRT. And also it uses the same TF-Lite file format. Just to also give you a quick briefing on what is the big improvement. So LiteRT is built with a new compile model API. The quick highlights for this is it's much faster. So have a much faster GPU, roughly 30 to 40% faster than LiteRT, TensorFlow Lite based. And LiteRT offers a new GPU backend, which is faster. It's much simpler. We have a new, basically, we are shifting from interpreter to compile model API that provides unified, streamlined workflow for deploying GPU and NPU acceleration. That's going to be a big focus of this hackathon. We also provide superior cross-platform support and the same flexible LiteRT model. All right, so we talked about LiteRT. So LiteRT LM is essentially the engine that is powered by LiteRT. Now here is for LLMs, when you're looking to handle context caches, you want to have prompt in, prompt out versus tensor in, tensor out. This is where LiteRT LM is going to be your go-to framework for running any LLMs where you're trying to go beyond tensor in, tensor out, but looking for more text in, text out. Right. So summarize this section here is supports cross-platform. The biggest improvements in LiteRT are generative AI support. We support advanced hardware acceleration. Specifically, we'll be focusing Qualcomm's NPU capabilities through the hackathon effort. And this is also a multi-framework support. So we also support PyTorch models, TensorFlow Lite, and other frameworks. I'll just run through two examples of where LiteRT is in action. So we also have LiteRT running in some of the more popular Google apps like YouTube and Google Meet, where it's basically running or powering on-device capabilities like AI-powered makeup capabilities, or even like use cases like background segmentation. So there's several real-world use cases where LiteRT is already deployed and is in action, improving user experiences and also helping with overall performance capabilities needed for these real-time applications. And And before I hand it off to Erin, I'll just also state that we also have a Google AI Edge Gallery app, which is also a good way for users to showcase and experiment the stack. So this is also free to download, and you can certainly play around with this app to be able to experiment with different LLMs that you like. With that, I will pass it on to Erin.
Thanks so much, Shishin. I'm here to tell you how to get started. So yeah, now you've seen some really great examples and gotten an overview of what LiteRT and LiteRT-LM are. So let's talk about how to kind of get a little more hands-on and familiar with the APIs before the hackathon. So the first thing is we have a LiteRT code lab for the compiled model API that Chintan mentioned earlier. This API is great for, and this code lab is great for getting started. It'll walk you step by step on how to run LiteRT image segmentation on Android, and it'll help you through the whole way. So it's a great kind of pre-work activity to do to get familiar with the APIs, to get familiar with running a model on device. And we have the image segmentation app on GitHub where you can go fork it yourself, and you can try it out and try out the hardware acceleration in particular. So if you want to see the model running on CPU, GPU, or NPU, you can go to GitHub, forks this app, and run the hardware acceleration yourself. The Gallery app that Chintan mentioned earlier is a really great showcase of a lot of the things that you can do with on-device AI. We have a lot of the basic use cases like just prompting an LLM, and we also have more advanced ones like agentic function with Tiny Garden, and a lot more. And you can see the source code for all of it on GitHub. So you can see how all of those use cases were done, how they were implemented, and Gallery app uses LiteRT-LM because it's running LLM. So you can go in and see how LiteRT-LM is calling the models, running inference, choosing your hardware, etc. All of that is in the source code that you can go check out and go find out for yourself. And then LiteRT-LM, we have a CLI tool. So we have that up in our documentation. You can use the CLI tool to download and benchmark and run models locally before you even put them in your device or in your apps. So you can use the CLI tool to kind of play around with different models, get a feel for them during your LLM explorations if you are looking around at different models or trying to choose which one might be right for your project. This is a great tool for that. And so finally, for the hackathon, when the hackathon starts, we'll show up with some pre-compiled models that you can use for audio, image processing, and general text models. And we'll have some sample apps. So it'll show, running inference on these models with these provided models. And so you can kind of just download these APKs, open them up, show, run basic inference, and then you'll be able to build on top of them yourself. And then we'll also have developer workflows in order to walk you through different workflows. So whether you are using a classical model or an LLM, either track, you'll be able to have a step-by-step guide in order to run inference and kind of get started using these models in your app or in your project. And then for additional resources, these are all up. You can check them out right now. We have our Hugging Face community for both LiteRT and Qualcomm, so you can go check out the models that we have there. They're pre-compiled and ready to run and be explored. We have our GitHub page, like I mentioned earlier, it has the gallery source code and other sample apps. And then, of course, our documentation for both LiteRT and LiteRT-LM, all of those are up now. They're available to get started with if you want to do some pre-learning before you get started hacking.
Yeah, so definitely recommend that. And there's some key things that I kind of wanted to emphasize, because I really appreciate the LiteRT LM flow, because for anybody that's been doing this generative AI stuff for a while, historically we've had to, you get the model, you get the transform, you have to manage all of your KV cache, attention mask, all of these things you have to manage yourself. So with LiteRT LM, it abstracts all of that. So now all you have to do is compile your model ahead of time and run it, and it handles all of that in the background for you. So that's super nice. Now another benefit as I segue into the Qualcomm specifics. Another benefit is now you can take your TF Lite. So we have, whether it's AI Hub, whether it's Hugging Face, you can take those models, compile them, do ahead of time compilation, and then get them delegated to run on our NPU, which is super nice. And Aishika and Kartiki is going to show you, just one workflow of how to make that happen. All right, let's go.
All right. So, Chintan, thank you so very much for the very thorough intro into LiteRT. It's been an absolute delight working with LiteRT and building these sample applications that we're about to show you. So we've got two different applications. We've got an implementation with MobileNet V2 via the Qualcomm AI Hub. And if we can pull up my screen, I'd love to give you an intro to the Qualcomm AI Hub as well. It's an all-in-one platform that enables you to run AI on edge on top of Qualcomm devices. So the model that we are going to be using for the first demonstration, there's also going to be a link on your screen. We can also drop it in the chat. It's going to be a link to this repository, which is going to help you get this specific model, the MobileNet V2. You're going to get it up and running via LiteRT. And then Karthik is also going to showcase, a demonstration on LiteRT LM using fast VLM. So you should be able to see the link in the chat for the first one. And I'll quickly hand it over to Karthik. Yeah, all yours.
Cool. Thanks for a brief intro, Arshika. Let me share my screen first. So.
And just while he's sharing, we will also have these sample apps. They'll be a part of the resources in the Google repo as well. So you just kind of have a one-stop shop to get all of this.
Yeah, cool. I know. Yeah, sure. I guess hopefully my screen is visible to everyone. So yeah, this is the first, because in Hackathon, 2 tracks actually is divided. One is for classical model, that is track 1, and if I'm missing out in that way. And second part is the language model that you can work around, which is divided on the concept of the framework LiteRT and LiteRT LM. So in this first one, we will explore LiteRT using MobileNet V2. And again, as Ashik actually already shared everything, so let me get into it. Okay, so if you see, I know Android is still like for a lot of folks who are beginner who want to get started with, it's a lot, but I will try my best to make it very simple for you. Okay, so let's go to the first thing, that is the main activity file. Okay, what you have to do. So generally, all things are linked with the processing part of it, but my major thing is how we can streamline and how we can create it. So initially, you have to create a function, specifically the constructor, to call the LiteRT engine actually, or like LiteRT engine majorly. Okay, so for that, first of all, let me give you starting with the backends, that is CPU, GPU, and NPU. So if you go to the this file that is called devicepolicy.kt, I will share the links in the comments so you can actually explore that. So you have to create a backend policy which have like CPU emulator, NPU required, and auto. Like you can majorly backtrack to the default thing, that is auto. Whatever it fits for you, it will fall back to it, right? You have to create a basic object for the device policy, like create in a form of class and all, right? Create a function. If you need specifically CPU, if it's not that heavy, you can do it obviously in that way, right? Apart from it, and yeah, this is the basic thing, how you basically structure your policy while going from one backend to another backend, because sometimes some ops doesn't support on specific backend, so generally it fall back, so you can create in that way, right?
So when you say backend, Kartiki, real quick, when you say back, what does that mean? Also, can you maximize your screen and maybe zoom in just a little bit?
Okay, for the code you're saying, or like
for the IDE for yep.
I hope so, because it's let me try. No, I guess this is the only maximum thing I can do. I'm hoping. Let me.
Okay, well, that's fine. Cool. Just briefly, kind of talk about what do you mean when you say backend? What is that? What are we talking about there?
Yeah, so when we talk about backend, it's like whatever the accelerator that is being used in your mobile phones. It can be firstly CPU, GPU, and right now, if we in this hackathon, we will use S25 Ultra, which has NPU obviously, right? And again, it depends on you on which specific backend that you want to use it, right? Again, it's an independent, like you can work on NPU also, that's not a problem. But if you think you can work on GPU and CPU on the same task, that you can do it. So when I say backend, it's specifically the accelerators, CPU, GPU, and NPU.
Okay. So basically, where we want the model to run, and we can choose whether we want it to run on CPU, GPU, or Hexagon, which is our NPU.
Yes.
Got it. Okay.
Cool. Great. Thanks for that. And this is the basic classifier that I built for preloading the Qualcomm libraries. As for that, it's already integrated with LiteRT. You just have to, if you go to the build basically. So what you have to do, again, it's just like I created this for testing and all, but you can obviously just is like NPU is available or not. You can check it like, and while you connect it with your phone. Okay. So if you go here, yeah. So this is the majorly GNI library, which is basically the Qualcomm SDK where it's stored. If you go to here, when you download it, you will seem like this is the files that you can see. While because Gradle before it built with because there's an integration happened already in the Gradle with LiteRT with Qualcomm SDK, so you didn't have to download it from someone here. It's already downloaded. You just have to build the Gradle for that. Okay. And after that, for specifically for model, again, this is just a sample packaging while when we package something around it. And if we go to the post-processing part of the classification, like how the model is working and all, right? But before going into that, the main thing is how I divide it. So when you downloaded the model from the AI Hub, right, it's something it goes like labels is in form of this. And let me open this, like whatever the, you can say object detection when we do, right? Because it's ImageNet in a way. This is the model, which is in .tf-lite format. So as Chintan already said, even though your model is on TF-Lite, it will work in a form of LiteRT. It's like a same kind of model type. So it will work same in every context behind it. And again, this is a sample, as you pretty much know, as is very famous from the machine learning community, as you pretty much know. I will go on it. But before going into that, let me do one thing. Let me do a basic demonstration. I guess that will be better, I guess. So yeah.
And just to be clear, so this model that you have in assets, this is after you do the compilation, the AOT, the compilation. So
yeah, so it's just for this example, it's just in time compilation is happening for this specific example. So it's not like you are already preloading. It's happening while it's inferencing actually. Yeah.
Oh, okay. Okay.
Cool. So let me take an image of it, even though, yeah. So let me take this image. Okay, and let me try to run it. So it's a Starbucks receipt image basically. So so even though I know it's happening on device very quick, if you see, right, it's obviously it is stating its menu. The reason is being because it's whatever thing I buy from Starbucks, right, it is encapsulated in that way. So this is the one of the quite good example that we can see, like on device, nothing. If you see, my internet is off here, right? There is no internet here, right? So everything is happening locally. And it is because that's what our major prominence around it. On device, when someone say in tech industry, privacy is a myth, we are here to prove that privacy is not a myth. Your privacy will be there in that way. Your data is not going anywhere, right? So this is the one of the example that I want to show. And let me go to another example that is of my the LiteRT LM where I'm using Gemma.
Well, before we go there, I guess I'm interested in, so how did we go from AI Hub to getting this artifact that you're currently running on the S25?
Yeah, so as I already said, you have to download the model from here. Again, you have to choose here, like take TF-Lite for that. Again, we have a precision. Again, you can use float, but like better, like weight 8 and activation 8 quantization models are work well, and it's universal. So the model is device agnostic in that way. And you can directly download the model from here. Basically, you get the artifact from here only, from AI Hub only. Yeah.
Okay. And then from there, you take the model.
Yeah, you can take the model from here. Yeah. Again, depends on like whatever the specific runtime that you want to run on it. So yeah. Cool. Let me go to our next part. That is the second track, or like another track we can say, which is like on the LM. This is a Gemma model. I know recently when Gemma model dropped, like community got crazy actually around it. So we thought of let's try something on that front. So, but let me cool. So if you go to the main activity, yeah, cool. So this is again the initialization. I'm not going into that, right? So I created a superclass for that. Again, this is the same sample how Android works in that way, right? And let me go. Yeah, so this is the part where like if you're choosing, because Gemma model gives you not only just the text interaction, but also with the image and voice interaction also. right? And again, it's happening again fully on device. That's not everything is going in that way, right? So now the major thing, let me go to the adapter part to it. That will be better, right? Basically the adapter and chat message is like a basic chat application, how it work on a system design level. So it's just like what are the item views, how to create view holders and all. So these two files are majorly for that. But my major intention is towards this file specifically, LiteRT element manager. This is why I created while running on it. It's nothing. You have to just create an engine config function, as you're seeing here, like literally. You have to pass the like directories, whatever the LiteRT LM, or like if you're pushing to directly to via ADB on your phone. So you have to basically pass or maybe a test directory for that, right? And whatever the library paths, if you are directly loading your QNN system directly on your phone, so you can basically write system.load memory, and you can basically see this is the GNA files if you're seeing here, right? So you can do that in that way. And yeah, again, this is the major thing that I'm stating earlier, like your priority should be NPU, but in case if any ops will fail, it will go back to GPU and CPU, and you can create in the if else condition for that, right? If it's fail, you can do cleanup. If it's failed, go to CPU, then it will check the LiteRT format for that, like this is a path basically for that particular model, and it will run on that way, right? Same like NPU, GPU, and CPU for that thing, right? Like this is the whole context behind it. It's just like you have to create an engine config constructor. You have to call that constructor in a form of function, obviously, and you can run it. You just have to pass the model path and your whatever the if you're working on suppose a RAG application, something like that, right? You have to pass your image embeddings and text embeddings for that, and it will work on, and using that particular model, it will work on it basically. So you can create, obviously, it's not only that you are taking a model and just try to use or harness the power of Gemma, but obviously you can build on top of it like RAG application, and which will be more optimized in that way, right? Because Gemma inference is pretty much better than if we talk about Gemma 3, like when we do benchmarking around it, right? So that's pretty nice actually. Yeah. And again, same thing with the model config. It's just to create a config function, just to go in that way, right? And again, in case if you want to incorporate with the QNN thing and you want to explore, again, you can do an inspector window around it, and you can basically check for every layer how it works and how the interaction is happening with the QNN libraries and all, right? And again, let me first of all, because I will try to show, because Erin told us like we have a LiteRT LM CLI. So let me show you one thing. So if you see ADB devices, we have like currently I have owning this device. Okay, I already have a you can say a command prompt already. So this is a basically a library. Like this is the main thing that I'm using. This is the library part to it. Okay. Because I am from Qualcomm, so I just asked that explain Arduino Uno Q, right? Or maybe I can create some. Just give me a sec. Yeah, Arduino Uno Q. So let's see. Okay, so it's working. It's on happening in CLI. If you see, my phone is heated up a little bit because it's using an NPU in that way. So it's showing Arduino Uno is the most popular beginner-friendly microcontroller board system for electronic project. It is essentially a small, versatile computer platform. So it's basically working on NPU, because if you see on my command, it's still working. But let me go up again. If you see on my command, I just passed my like hyphen backend equal to NPU. You have to just specifically, if you want to test on your laptop before pushing to on your Android app. So you can use this CLI to understand like the NPU is working or not in that way, right? And again, this is the major crux behind whole the developer workflow, if you will say. But if you go to let me explore this thing also so that it will be better for you. Cool. Again, because here, if you want to deliberatively work on Qualcomm libraries directly, so you have to just create an NDK path file for that, and just to pass as a parameter here, right, for that. And let me go here so that you just have to add a dependencies, like for here implementation like LiteRT LM, it takes a latest release for that. And if you want to go for the embeddings part, you can use that if you want to do embeddings and all for that. And again, as I'm testing with some of the LiteRT stuff, because it's obviously a .LiteRT model in a way, so you can obviously incorporate this thing, but you didn't need it. Like it's just like these dependings are enough to basically run on it. And again, coroutine is very important because it's happening on device, it's happening in a parallel way. So coroutine, if you do those folks do those who do not know what is coroutine, it's just like an async functionality like JavaScript. If you ever worked with JavaScript, so it's just an async environment, you can say, to basically do everything which is happening in parallel actually. So yeah, I hope so. You understand whatever I share, but I hope so people understand about the basic developer workflow that we go through.
Yeah, thanks for that, Kartiki. So just at a very high level, what is the process that that developers will have to go through if they want to access access the NPU?
It's very easy, by the way. So you don't have to actually, I downloaded some of the QNN libraries, but you don't have to do it because it's already integrated with the build Gradle actually. So you just have to add a dependencies or LiteRT LM if you're specifically using any language model like Gemma, right? You can directly just add the dependencies over there, and just you have to run the build for that, and Gradle will build it, and it will directly incorporate that particular directory in your you can say Android environment basically, right?
So it automatically pulls all of the drivers that we need for the NPU, so we don't have to do any going to Qualcomm, grabbing QNN SDK. It automatically links everything for you.
Yeah, that's I guess everyone's like, people think like how we can incorporate so much binary, because that's how we're improving. And again, Google and us improving the developer experience around it, right? Just people didn't have to go from another to take another one binary, then try to integrate with something else. So it's all, everything is on in your Android Studio. You didn't have to go anywhere actually. Yeah,
that's awesome. So can you speak to the pod AI, the how that works?
Sure. Okay. Yeah, I think so. I missed that, but let me share my screen again. Yeah. So sorry.
Yeah, because I think AI Pack is a very cool way of getting these drivers and getting the collaterals that you need to access the NPU. So
sure.
At high level.
So yeah, I hope so. My screen is visible to everyone. I'm hoping.
Not yet.
Okay. It's pretty odd. Okay. So sorry, I didn't able to share that. Let me know if it's visible now. I'm hoping it's visible now.
Oh, almost.
Yeah, cool.
Yeah, see it.
Cool. Yeah, as I'm also a Google fan, so anti-gravity for when. Yeah, cool. So AI Pack is, so you can do actually your deployment in two ways. One is obviously go directly build from your QNN libraries and try to build on it. And second way, from your Play Store access to it, which is like your AI Pack, which is incorporated with your Play Store. If you are an Android developer and you didn't have to go through the whole process of the binaries thing, what you have to do. So let me go to the source part of it. That will be easy for you to build actually. So just give me a sec, folks. Cool. So I created this Python file, right? Again, it's available. So I and Ashika actually work on it. So you can go to this repo and you can explore it. Okay. These are all the builds that you required. Again, these are the main thing, or the builds that you want to build on it, right? This is the Hugging Face release. If you want to access the assets actually. This is the runtime zip. That is that's Google runtime zip for the NPU runtime library. So you didn't have to download it also. We created this Python file, so you just have to run this Python file and it will work. Actually, everything we built in one place, so you didn't have to do it from different ways. Okay, and again, it's downloaded. So basically, the whole Python file actually explains the building of the whole from NV files to everything. So you don't have to do it anything, and you can directly push that thing to your Play Store directly working, and integration can happen around it. And again, if you want to explore that thing, if you want to benchmark it, that's also a good way you can do. Again, all the models are listed. It's just like here, like it's downloading, it is working on the release relay. So it's basically whatever the model that you wanted to work on, you can take it and you can build on it actually. And you can pass whatever the like assets file folder and directory that you want to use on it. Okay. And this is the whole thing, like to just fetch the Qualcomm NPU and runtime binaries for that. And again, same, if you want to go for ahead of time packages, this is the thing you can basically, it's just basically testing is the QNN target is working well or not with the specific devices and all, right? So again, this is the whole thing. And again, you can compile on different ways. JIT is also way, but again, AOT is far more better because already compiled already before going for the inference. So the speed will be better than comparatively to JIT in that way. In this particular project, because it's a MobileNet is very a small model, so you didn't have, you can do AOT, but like just JIT is very easy, like it's just like it's happening on inference, so we can show you in that way. So yeah.
And can you go to that that device targeting configuration really quick? Should be under AI Pack, the subdirectory.
Sure. In this one?
Yeah, so the AI Pack subdirectory.
Yeah, okay. So if you go to
Directly,
AI pack,
it should
yeah, and
be
there's a build section actually. So yeah, it
in-
basically, so you have to pass a model, specific model group for that, whatever TF light model that you have to go, and it will build on it actually, and it will basically, it will generate here. It's not like you're working anything or changing any code. It's you just have to run this particular Python file, and it will basically generate a specific model type for your AI pack actually. Yeah.
Yeah. Can you click on that XML? I just want to show something that's really cool. No, the device targeting is down,
Okay.
under, keep going. Yep, right there.
Cool.
Okay. So what's also nice about this is that, with this, you can push a model to Pod AI using AI pack, and then that model, you can specify multiple different devices, and it will, I mean, this is just targeting the S25, but you can target a whole bunch of different SoCs, different types of phones. And when somebody downloads the app, it'll automatically know what collaterals will be needed. So when you're developing your app, you don't have to go through and create the different collaterals for, say, an S25, an S26, whatever other system uses Qualcomm chips. It will automatically build this device targeting config, and in real time, when a user downloads it, it'll automatically pull those specific collaterals. So that was one thing I thought was really cool, because you don't have to manage that yourself.
Yes. You just have to add in your XML file, and it will totally integrate with whatever the SoC that you want to do. So you don't have to interact so much. You are like you just need to build your Gradle, and that's it. Everything is taken care of the LiteRT and LiteRT file, like libraries actually. Yeah.
And then in that tools that fetch, I liked how you had the in that when you download the LiteRT NPU runtime libraries, it's just a simple, bash script to get everything downloaded on your system already. So they really made it super easy to deploy models, to run models on the NPU without having to go export crazy, follow dynamic linkers that aren't working, linking to the wrong drivers. They really make it kind of seamless, and I really appreciate that, because it can get crazy real quick. Did you want to add anything, Chintan?
Yeah, I was just going to ask, maybe Karthik, with your experience with the LLMs and like MobileNet, is there any key differences with Pod AI, and also overall experiences on what the users should keep in mind with the LLMs?
Yeah, so there's one good thing with LiteRT LM. You don't have to go on the KV caching thing, right? That's a plus thing in LiteRT LM, right? But before, if you want to try to implement or if you have a fine-tuned model, you're bringing your own model in that way, right? Try to focus on, because when you're building NPU bundles, actually, you have to just pass that specifically your NPU library, actually, whatever you downloaded from your build and Gradle, basically. The reason is being because generally it's the priorities you can add in your policies, like NPU is the priority, maybe then GPU, then CPU. But obviously, if you didn't passing that particular parameter for that, it will fall off to maybe CPU. And the reason is being CPU generally, it's the main thing where actually phones work in that way, right? Because again, we say CPU is the brain of, or you can say is it managing all the workloads that you're working on on your mobile, right? So prioritization for that, and you have to be very specific around it. Again, as of now, LLM is not the thing that we're going up in the sense, like, but small language models, right? We are seeing there's a lot of potential coming, not only with the Gemma models, but in general, open source community is actually pulling off, contributing small language model, making, or like, small language model is already a quantized version of the big models, right, in a way, right? But it's people are also fine-tuning for their own use cases that specific. So model is becoming smaller and smaller. So running in faster inference is obviously a great play of it, but it's just your ideas, how you are bringing, what are the idea that you want to implement. So you can take Gemma and you can fine tune it. And again, it's another scope of building more models around it. So that's a major pointer that I want to share, but yeah.
Yeah, and that's actually pretty cool, because with this flow, you can technically fine tune the Gemma model, because we have the recipes, we already have the way to delegate to NPU. You can fine tune a Gemma model and because you're only updating weights, you're not changing the graph typically.
Yeah.
Even if you're using LoRa, you bake that back into to the projection matrices, and you can delegate, you can get that fine-tuned model running on the NPU as well using LiteRT LM. So that's another, I think, like you said, Kartikeya, the fine-tuning is going to be the big unlock. That's where I find myself a lot of times, and being able to fine-tune a model, get it running on the NPU relatively easy is huge.
Yeah, I just say, folks, if you want to accelerate, in the sense like if you want to build good thing, fine tuning and quantization, it's just for me, but fine tuning and quantization are the best way to, you can understand a model pretty much better, because sometimes you never know whatever the specifically custom data set it built on, but fine tuning and quantization actually helps you in that way. So I think so for me, if someone say what is the maybe key to a successful or good model, I think so quantization and fine tuning is the great way you can understand a model and try to, again, you can obviously build on whatever the use case that you want to build on it, right? You can test on the benchmarks on that front. So yeah.
And I see we have one question. Oh, we just had another question. So I guess we've kind of segued into our Q&A. So one question was, for Qualcomm AI Hub, do we have direct access or do we need permission? Any process for us to follow? So you actually have a couple of ways. You can go directly to the website, as Kartikeya, as he showed. Just download that TF Lite model, do the ahead of time compilation, and get things running. You also can use, they have a Python API that you can also use to download models as well. Both of those pathways are actually in the MobileNet example that Kartikeya and Aishika put together. So another question, is it possible to have some credits on Colab to do some fine tuning? You know, that's above my pay grade, but I'm sure if there's a will, if we get it, yeah. If you're talking about for the hackathon, maybe that can be, if you're joining the hackathon, maybe that's something, because that would actually be pretty cool. But just in general, I can't answer that question.
Maybe what I can, because I'm a big fan of open source. Okay, for whoever asked that question, you can contribute to it if you think in that way. And like when someone say credit, it's obviously for me, if my name is as a contributor in that particular GitHub repo, right? Again, it can be anyone. Like if you're specifically if you're optimizing on the LiteRT LM or LiteRT in general, or in general on the Google stack, you can contribute to it via like on the collabs and all, right? That's a pretty much, but this is my take. I can't say on others work and all, but yeah, you can work on open source for that. People can get used to it. Community will engage with it. Community will contribute to that also. Whatever you're building on it. So yeah, that's my take on it. Yeah.
So I guess I have a question as well. Oh, so yes, for the hackathon. So if somebody's trying to fine tune specifically for the hackathon, and I'm sitting here talking to the people from Google who run Colab. So maybe there is an opportunity there, but let me not speak for them. So what do you think, Chintan?
Sorry, yeah, the question is essentially if we can have credits for collabs, right?
Yeah, during the hackathon.
I don't think we've planned for it, but we can certainly find out and see what can be done. So awesome. Yeah, at this point, yeah, there isn't a plan for any credits for that, but we'll have to check and see what's possible before the hackathon.
Mm-hmm.
If I may, you can also do a lot of things on the Qualcomm AI Hub. So it might be worthwhile to create an account if you don't have one already, explore the platform and see how you can optimize your models to run on edge devices. You might not need credits for Colab after all, if you check out AI Hub. Just a shameless plug.
Yeah.
No, thanks for that. Yeah.
Yeah. And then so somebody else asked, can we use Claude Code or anti-gravity to assist? Please do. You have 24 hours to get through this. So we definitely encourage you, whatever LLM you want to use that so that you can focus on getting your project, understanding your project, and getting things running. It doesn't have to be fully production scalable. Get something running, get something cool so you can get your prize. Which, speaking of prizes, did we mention what the prizes are?
No, don't think we have. We do have Nintendo Switch 2s for the prizes, and it's currently planned per team. Mm-hmm. So each participant gets one for the winning teams.
So this is what you're winning. So get something cool up and running. Highly encourage you also to go through and just kind of ramp up on the flows. You don't necessarily need to have an S25, but understand, what things need to be plugged in, where things, how the plumbing works, so that once you get into the hackathon, you can just hit the ground running. So yeah, we definitely recommend that. I guess another question for me, since it's kind of the questions have slowed down, is what's the future of LiteRT, LiteRT LM? Where do we see this going? I guess that's for the Google team. Like the future, yeah.
Oh, your question is what's the future of LiteRT and LiteRT?
Yeah, like where do we see? Where do you all see this going, or what's?
Yeah, I think it's a great question, and thanks for asking. Essentially, as I mentioned, like LiteRT is built on essentially TensorFlow Lite as a follow-on, and the goals were to make this more accessible from the point of supporting a wide range of model formats, PyTorch, TensorFlow, JAX, etc. And now we are also working on expanding towards additional platforms, like I said. So we really want to ensure that when you are deploying models on LiteRT, you are also able to think about your larger strategy if you're targeting additional platforms. And part of that, we want to improve acceleration on CPU, GPU, and NPU, right? And on all those fronts to allow you cross-platform performance and also being able to take advantage of the latest and greatest accelerators, right? So we want to simplify this and give you the right level of performance so you can realize your application's full potential.
Okay. Yeah, no, that's cool. And I think that's super important, even though, of course, the best accelerator is going to be Hexagon. But if you want to play with other accelerators, LiteRT does allow that, allows you to do that. And yes, you will get a hoodie. And I'm telling you, these hoodies are awesome. So that's cool as well. Thanks for reminding me of that, Aishika. So does anybody else have any questions? Or let me go and look at Discord and see if anything's popped up over there. So Kartikeya, what do you feel like, what should people focus on the most, bringing these flows up? What's something that if they nail this down, they'll have a seamless process of getting, of delegating to the NPU. What would you say?
Okay, so yeah, obviously we show developer workflow, and we will share a proper fully fledged doc where you can explore what is the developer workflow for it. I must say, try to use pre-compiled model which is already there, because we did for you, so it will make your life very easy while in the hackathon, right? So you take the power of your already pre-compiled model that we will share on that particular deck and on the particular talk. Apart from it, be creative. It's not only on the developer side when we talk about, because hackathon is all, because we folks know we have vibe coding tools, you can build on it and again, right? But try to be very creative while getting a specific idea, and you never know, whatever you are vibe coding it, maybe it can become your next startup. Maybe that's what I feel around it. So be creative on that way. But obviously, if I talk about specifically for NPU, like NPU bundles, we already have some collected some models. Take inspiration from them, try to use it, and make a build on top of it. Like, we will love to actually see a lot of thing on it. But I guess maybe Chintan, if you can add something on your side.
Yeah, I'll also add is what I would say is there is going to be like what you will do at the hackathon, and then there's also probably what you really aspire to do yourself. So I would say for the hackathon, since it's like a Google Qualcomm hackathon, like a lot of the main focus is around like LiteRT, LiteRT LM. So I would definitely say get familiar with that. And, thanks to the apps shared, by Qualcomm team, feel free to like play around with it so you get a little familiar. So you have less time focusing on, the internals of like the runtime and all of that, but you can actually build your experience out. So I would say that is going to be good, is just to get familiar. And, we've also shared some other collateral with Gallery app and things like that. And there you can also, go to GitHub and clone it and try to experiment with that. So there's going to be a couple of options for you just to get familiar with like on device, so the two apps that Karthik and Aishika sharing, there is the gallery app, which is on Play Store. You can also get it on GitHub. That also helps you experiment with LLMs. And also you can build on that app. So there's going to be a bunch of things just to help you get familiar. And if you're interested in the more classical or traditional model side of things, then we have the MobileNet app also that should be easy to use. And we also have another one that I shared on segmentation. So there's a bunch of resources, I would definitely say. And once you get the handle of it, I think what's good is with cross-platform capability on LiteRT, you can certainly extend it to like other platforms, like in this case, like Qualcomm supporting like IQ8 or like AR IoT platforms, or even like laptop and desktop, and really try to get maximum reach for your app, right? And yeah, I think I would say that, and maybe it'll be good to touch also on if when the participants complete the app, like where they expect to see it hosted, and some of that'll be good to cover at some point.
Yeah, and typically what we do have an awesome repo. So these apps, we will, if you're keen, if you want to, we can help try to get those published on our official repo, our awesome repo. And then we've done things like some of our other hackathons help people help get their apps published on some of the app stores that are out there. So maybe there's a pathway there as well. If you do come up with something super compelling, get it on the app store. So we have some more questions. Let's see. So is there an SDK for Unity to be run on Meta Quest 3? So I'm not sure about the first question. I will say that we do. I mean, Meta Quest is ran on Snapdragon, so there is a path to the NPU for sure. Can you speak to that, Chintan?
I'm not aware of one SDK for Unity. I haven't looked into it. I think the hackathon is on S25 devices, but there is probably, I haven't looked into it, and I'm not sure about running on Meta Quest 3 with LiteRT. But there's probably something that Meta is offering, which I don't know about.
Mm-hmm.
So,
and I guess, what about switching their project idea?
Yeah, I think definitely if you the way the hackathon is structured is team-based. So, if you and your team are looking to change your idea, you can definitely switch your idea. I think the only constraints really are that the end app needs to be built on S25. You should be using LiteRT compile model APIs, right? Not like the older TensorFlow Lite. So that is definitely the two minimum requirements. And then, beyond that, you're welcome to change your idea before the hackathon.
And then we have another question. What would you recommend setting up before the hackathon? So what we recommend is going to the repo that Chintan shared. That will get you, we kind of look at that as like pre-work, so that you can start ramping up with the flows, understanding how to delegate the models, understanding how to compile the models. So definitely look through that. Also the repo that Kartikeya and Aishika showed, but that will end up on the Google repo as well. So those are the resources that you can use just to, kind of get started. Just so you don't have to figure all of this out, on day one. So what is the judging criteria? For example, end-to-end working, idea, novel use case of the LiteRT stack? Yes.
We'll be posting details too, I believe.
I can take that one. So you should already be able to check all of that out on DevPost, and you may have already received the link to register for the event if you're shortlisted. And the judging process, all the rules and regulations, everything's very well defined on DevPost. So please take a peek. If you have any other additional questions, we are all going to be on site to help you out. You can also reach out to us over email, and we'd be more than happy to help you out there.
And I'm not sure, but do we have a Discord setup, channel setup for this hack? If not, we should probably get that.
It's in the works, so we should be able to get people onboarded really soon. So leading up to the event, we are also going to release a developer journey guide, very similar to what we showcased today. And that should also be able to help you folks get up and running with LiteRT and building your applications towards your project submission.
Mm-hmm. And then, we just had one more question. Is the hackathon on site? Yes. There's no remote. Yeah, no remote for this hackathon. Judging criteria. Okay, yep. So Qualcomm developer just answered that. Yeah, well, that's all our questions. Did anybody have any other comments before we close up?
Yeah, I mean, I think, just to kind of reiterate, for key things to check out to get ramped up, I think if you're interested in LLMs particularly, the best thing to check out would be the LiteRT LM CLI tool to get started and the AI Edge Gallery app. Both of them we referenced earlier in the slides. And then if you are interested in classical models and that type of architecture, the best thing to check out would be the compiled model API. So yeah, those are just, if you want to get started early, those are the best resources to look at. And we, like was previously mentioned, we will send out the developer paths soon.
Mm-hmm. And then DS Gaming asks, do we have to stay on site during the entirety of the hackathon?
You don't have to. Yeah, you can come in, and if you want to, head out, come back later, that's fine. Essentially, you can imagine, there is going to be, the agenda is posted in that post, but the point is, you can actually take off and come back again the next day, depending. And there's also Discord to help you out. So
Yep. And you can technically take the night off, but typically the next day people are like, by the time submissions are in, we have people sleeping in rooms, and so typically it's an all-nighter that people are pulling for this. Well, okay, so we look forward to it. The hackathon actually starts on Thursday. We'll set up the Discord live so we can just answer some basic questions that you may have. Definitely figure out how to get ramped up, understand the workflows, so that on Thursday when we see you at Google headquarters, you can hit the ground running. All right, have a good one. See you on Thursday.
Bye-bye.
See you, folks.